My name is Jim Potter of J.R. Potter & Associates of Cleveland, Ohio. We are an authorized stocking distributor of both the Carr hydraulic swedging tools and the Rexnord cutters and roller swedging tools. Using a component from a Bell 206 helicopter, we will now demonstrate the use of both tools. Even though these actions can be done right on the aircraft, in order to demonstrate the tools with the use of our video camera, we will perform the removal and installation of the bearing on a work table. It is very important to use a cutter when removing the bearing installed in an aluminum or a magnesium housing. Pressing the bearing out without cutting the lip can cause a broaching of the housing bore, which may necessitate that an oversized bearing or a sleeve be employed as a replacement. First, unscrew the cap and shaft assembly from the clamp nut. Next, insert the cap and shaft assembly into the bearing bore and tighten finger tight. The tension on the cutter face is accomplished by hand turning the clamp nut at the end of the cutter portion of the tool. The cutter is then rotated clockwise using a spanner wrench. On some cutter models, you will have a hexagon nut instead of the spanner holes to rotate the assembly. Continue to rotate the cutter until you can feel that no more cutting action is taking place. Remove the cap and shaft assembly and using a hammer and punch, lightly tap the bearing. The lip portion of the bearing should pop off and the bearing can be pushed out. Next, check the housing bore for tool marks or other irregularities that could affect new bearing installation. Prepare the housing bore per the applicable overhaul instructions. You are now ready to use the new Rexnord portable roller swedging tool. This tool utilizes the best features of the drill press mounted roller swedging tool as demonstrated in the second video, but allows the user to take the tool right to the limited space application, often right on the aircraft. The tool has 3 freewheeling rollers spaced at 120 degrees. These rollers are made of hardened tool steel and should last for many years with proper care. The tool is inserted into the assembly as shown and tightened finger tight. The tension nut is then rotated 30 degrees or 1/2 of a hex flat. The roller end of the tool is then rotated 3 to 4 times to even out the detent made in the bearing lip by the pressure of the tension nut. The roller end of the tool may be rotated with the use of an open end or box end wrench when the assembly has an oily surface or the operator is wearing gloves. After the first 30-degree tightening and rotation is accomplished, turn the tightening nut another 30 degrees and rotate the roller end of the tool 3 to 4 times. Use this method for a total of 6 tightenings. This will affect about 180 degrees of tightening on the tension nut. Caution: do not turn the tension nut greater than 30 degrees on any tightening cycle, as this will put too much tension on the tool and can cause tool breakage. Loosen the tension nut and remove the tool from the bearing assembly. Examine the bearing to determine if the lip rollover has been accomplished. This can usually be done using a 5/1000 feeler gauge. If the feeler gauge will not fit between the bearing lip and the assembly into which it is being installed, that would indicate that a satisfactory installation has been accomplished. If a gap of greater than 5/1000 exists, additional tightening on the tightening nut in 30-degree increments and the rotation of the roller end of the tool should be done. After one more cycle of tightening and subsequent turns of the roller end, remove the tool and again using the 5,000 feeler gauge, check for clearance. Terminate the tightening cycles as soon as the lip to housing clearance is 5 thousandths or less. Your overhaul manual may have its own measurement standards. If this is so, follow your manual. The tool should be removed and reinstalled with the roller end of the tool positioned on the other end of the bearing. Additionally, the support ring should be turned around so that the convex side of the ring fits into the expanded groove that was just formed. The new side of the bearing should be swedged using the same procedures as employed before. Some assemblies will require proof loading after assembly. You should use the procedures that are specified in your maintenance manual or tech order to conduct this testing. Under normal tool use, there should be little maintenance required. A thorough cleaning of the tool and a light coat of lubrication oil will give the tool a long life. Examine the tool before and after each use for damage to the rollers. Damage may occur if the tool has been used on the wrong bearing or if the tool has been dropped onto a hard surface. Replacement rollers are available. It might be a good idea to keep a spare set of rollers available for AOG jobs where a delay cannot be tolerated. Portable roller swedging tools have few parts and all are replaceable. Detailed instructions for tool maintenance are supplied with each cutter and roller swedging tool.